Hi, it's John M0XFX. Okay, today we have a 2955A Marconi test set on the bench. It's failing its self-test. I've just bought this and picked it up from a chap in Surrey. I bought this primarily not to sell on. This is for a good friend of mine in Yorkshire, the Cobra-man, and I know he really wanted one of these because he does a lot of repairs and to radios, and these are ideal for that application. I mean, that's primarily what they're designed for. You know, you can repair a line, fault find, you do all sorts of things with them. There's a lot of features in these. I'll go over that as we go on, but this one is failing its self-test, and if I take you into the screen, what we will do now, if I don't know if you can see that, you will see, obviously with the sync, see sync, you know, I can't remember the interference bars because of the, you know, obviously it's a tube and it's scanning. But funny enough, you notice the bars, the interference bars go diagonal. On a conventional sort of TV or whatever, they go vertical. It's because these scan instead of left to right, they scan from top to bottom. But there's a piece of useless information for you. But anyway, right, let's see if we can zoom in a touch. Let's see what it's doing. See that there as well, so it's flashing. That's your signal to noise meter. They all do that. I don't know why, but if you hit set it over to silent, it switches off. It's okay when you're injecting sound into it, you know, audio, but they just do that. Anyway, I'll stop rambling. Let's put it into its self-test. Use that one. All tests. Okay. Failed. But basically what this is, it's just running the logic in there, there's a program, and it's just running a routine that, you know, it's measuring itself basically. Now, a lot of these ones with the one next to it, you know, it's injecting a signal into itself. But you see all these have failed. These tests here with the ones next to it, I believe that's the comparison. It's got a SIG-gen in there, and it's the comparison of the SIG-gen to the frequency counter. And these 12, 14, 16, 18, without off the top of my head, but I would say that these, I think they're all low frequency, and 1A means there's no SIG-gen reading at all. Okay, well, if there is quite some information on the internet about these, I've repaired quite a number of these units, to say the least. A lot of people seem to be frightened to go into them, but to be honest, the electronics in them and the manual, the service manuals and everything, they're very well written. They were designed to be repaired. There's very good explanations on the circuit details. And you know, it's all through-hole technology they're getting on, but as an instrument they're a great bit of kit. You know, they're no good. They're good for doing AM, FM transceivers. You know, they won't resolve sideband, but you know, to be honest, you don't really need to. What you need to set up with sidebands to do with a frequency counter and a scope. Anyway, yeah, there's a chap. His name is Jose Gavila or Gavila. I don't know. He's Spanish. Very nice guy. Very helpful. I've been conferring with Jose over quite a number of years now. His call sign is a ham is EB5AGV, and he does sell a lot of spare parts of these things, so it's a good thing to bear in mind. Okay, well, let's have a look at what the problem is the SIGGEN. Now, I know what the problem is because this is a very common fault with them. And there's a board that's on the underside, at the front here on the underside is the AA2 board, which is the frequency counter board, or is the RF counter board. Okay, well, let's have a look at the circuit diagram. Okay, well, what we've got is two ICs here. Now these are normally the problematic ICs. Well, we'll take a look at them. I'll explain why these play up quite a lot. These are the OM345. But basically what happens is you've got the RF signal comes in. We've got a bit of pad there. The relay just switches over. And just literally, I can't remember how many, it says on it's 20 dB pad switching, it even says it on there. This comes along, obviously decoupled, and goes into these. You've got these two ICs, and this is the AA2 RF counter board. Now, if you've got problems, it doesn't necessarily mean that with the 2955, it doesn't necessarily mean that these are the problems. A lot of people just go ahead and we'll swap these out as a matter of course without actually doing any testing. But you can easily test these to find where the problem is. And what happens is you just lose this signal path, which then carries on. You've got a limiting amp, Smith trigger, which basically will be shaping the sine wave here, the frequency, into a tidying it up. So that'll limit it. So you'll keep a set amplitude with some with a bit of negative feedback there, and it's a Smith trigger. So basically, you'll be getting I should imagine a square wave type waveform from here. Comes off. We've got a I should imagine that's a reference coming in down to pre-scaler, which is basically just divider, and then that will come into, well, this is your frequency counter here, and and there's this here which will be the reference, I guess. But this is what we're interested in. Well, let's get the unit apart and have a look at these ICs. Okay, well, we've got the unit apart. This is the AA2 board. I want to stick my fingers in here. All this is CMOS technology, so obviously when you work with this type of equipment, you really got to observe. It certainly pays to observe good electrostatic shit, grounding, just obviously, all this is electrostatic. We've got wristbands and whatnot, but you need to use that. Okay, these are the ICs. We've got IC1, IC5. These are the OM345. You can actually put OM2045s in here. They're exactly the same IC. The 345 is manufactured by Philips, and the OM2045 is manufactured by NXP, which is Philips basically. But when they went over to NXP, when NXP sort of started happening, I don't really know much about the history, they changed the name, the number on them to 2045s. they are essentially the same thing. Now, what tends to happen is these units are, there's a ceramic, it's a hybrid amplifier, and it's on a ceramic substrate. Obviously there's all the little components in there that make it up, and then they dip it in this material similar to what they, like capacitors, they dip it in this stuff to seal it up. Now I think what happens is over time, like damp from the moisture from the air gets into these things and they start to play up. But I've actually found if you give them a bit of intense heat, sometimes they come back to life. I wouldn't rely on that though. If they're playing up, you do need to test them. You do need to replace them. Other things you can get problems with. People have had, this one has been out before, I can tell. There's a bit of a knife and fork job down here. See that? Someone's probably had the board out and obviously decided to desolder this. It's a mess, I'll be tidying that up. It's not good to leave messes on, especially in test equipment. You want, it's very straightforward and simple. You've really got to keep them, keep everything spot on. I mean, you've got no room for error. Instead of soldering that, I'd see, I've just got to undo that nut there, obviously, and this RF connector comes off. Undo that nut and that unit will come straight out. Okay, well let's get the scope on it. We'll inject a signal and see what this is doing. Okay, we'll just turn this bench light up, you can't really see. Right, I'm using this is Hewlett Packard 8657B. It's the SIG-Gen. It's basically 0.1, which is 100 kilohertz, to just over 2 gigs. This baby will do. Great bit of kit. Modulates AM, FM on the carrier. You can inject stuff in. I won't go into all that. Nice bit of kit. Very stable. Quite dated, but it's very good. It's in reasonable calibration. Now I'm currently injecting 20 megs at positive 12.3 dBm. That's quite high. This thing will rock that out, no problem. But what I'm doing, I'm actually injecting this into one. I've got a couple of a few of these, and if I can get this what's name straight, let's put the light back on. Just setting that bad boy down. You can see that's giving me 20 megs on the readout, and it's giving me a power reading of 4.2 milliwatts. Incidentally, I am sending an FM signal, deviation about what he set at 5. So as you can see, that's going 4.9. That's what it's reading. The tone that I'm sending over there is 400 hertz into it, and that's giving me 400.2 hertz back, and the deviation level of 4.87, which is what I'd expect to see. This is in reasonably good calibration. So, okay, and that's in via the 1 watt input on the unit. So let's take that out of there, put that into here. You can hear it. Now this is upside down. Frequency, it's not giving me anything. 16.3 milliwatts. Well, I'd say that's reasonably accurate. We're talking about 2 milliwatts. So, I'm not really that worried about that. So that I'm quite happy with that. It's detecting the mod frequency. Frequency deviation level. It's telling me it's 5 kilohertz, which is good. So the only thing that's really not working on this is the frequency counter. Okay, well I've got the the main light off on the workbench, simply because it overloads this camera. But if we get back to here, pin 1 is the input and pin 5 is the output of these amps. And obviously IC1, IC1, IC2. If we look here, IC1, IC2. Now, get the scope. Got this set on times 10 because obviously I don't want to load the circuit. If I go on pin 1, I have to turn the light off as well because this scope of mine does not like this camera. The camera doesn't like the scope. But you see, we've got a, there's a signal going in on the input. Okay, and if we put this on to the output, I don't think there's anything. There's the problem right there. I mean, that's it. We could probably just get away with changing this one, but to be honest, if one's shot, you can guarantee the other one's going to go. There's quite a number of these OM modules. I mean, you can go and change them all. Now, the next problem is actually getting one of these things. These have been obsolete for a long time. There are some people out there with some ideas of changing the oscillators, but unfortunately, I do run a components shop, and I do happen to have a box full of them. Don't ask me for any because these are not for sale. These are, I think these are the 345. Just have a look. Oh, in 345. Yeah, Philips. Right. Okay. Well, what we'll do, we'll get this board out, and we'll get these ICs out, and get them replaced. Okay, we've got the board out, the AA2. I've had a look at this. Somebody's clearly been in here. When I removed the screws, and there's some fixings there. God, I don't know what you call these things. There was no washes on them. When they were manufactured, they would definitely have had washes on the. They're missing, but hey ho. Obviously, these are the two ICs, here and here. As I said, we knew there was a bit of damage there. I say damage, somebody's obviously been playing with it. Again, that would never have come out of Marconi in that state. Look on the underside. There's been some work on here. There's no damage. And again, somebody's been in since it was manufactured. This IC here, which is this, it's basically an amplifier, I think, or is that the pre-scaler? It could be a pre-scaler, I'd have to check, but that's got flux all the way around its joints there, and it's actually slightly offset as it's in. It's not particularly a problem. It's obviously been, replaced. I should imagine it's replaced for whatever reason. They haven't cleaned the flux off the board. Again, it would never have come out Marconi like that. Also, I found interesting, there's this diode here, but that's been soldered across these pins here. Again, that would never have come out of the factory with that one like that. Not that it's a major problem, but these were built for primarily the military. The government bought a lot of these, and their standards are very high. That's where the diode should sit. So the diode there. So someone's obviously had that out. the legs weren't long enough, so they've, you know, so we can find it. There. Legs weren't long enough, so they've soldered it across the pins. Again, no major problem, but I wouldn't really like to, you know, shouldn't be like that. Okay, well, incidentally, I didn't show you on the video, before I did the testers, I did some check the voltages were correct, supplying these. They are. It's something you should test as well, mate. You should always do that. It's just make sure your voltage rails are correct. I've got my gloves on. They're very grubby. I need some more static gloves. Obviously, I don't like handling this gear, and again, we're on the static workbench. Okay, well, let's get these bad boys out, and we'll go and replace. Okay, well, I've removed the OM modules. I've taken a look at the board. I'm going to leave that Zen, I think it's a Zener, it was on the underside. I'm going to leave that as it is. I don't have one in stock to change. I'm not going to mess around. I'm going to clean that up with some isopropyl. If you look here, very interesting. 10th of August 1989, so it gives you an idea how old these are. Now I pulled the other ones out. These can be quite stubborn to get out. This one here I had to cut out because one of the pins were refusing to go out. This one came out without any bother, and when I removed it using, I've got a desolder. Here, this nozzle's not particularly. I need a smaller nozzle on it, but there you go. And I've got two new ones to go in there. Yeah, again, the reason I'm not selling any more of these is because I simply can't get any more. And I keep the last few I've got. That box was full, but it's no longer full. Trust me, there's only a few in there. So, yeah, I can get these. There are suppliers I've got have them, but they want absolutely ridiculous money for them now, which is a shame. And they're not the 345; they're the 2045s. You know, we're talking in the region of $50 US each. So there you go, giving Yo-Yo a plug. That's our company. We sell all manner of electronic components. Yeah, okay, well, let's get these in. One thing before we go, just to I've sold a lot of these, and because I've seen people make the mistake. You would naturally think that this would be pin 1, but it isn't. It's below where it says 1. That's pin 1 there. There. If you look on the board, you can see it's pin 1. Pin 1. So if you do change these, you know, because they use them all manner of test gear. I don't know why, because I don't know why they use this IC, to be honest, because these were made for car aerial amplifiers, for so you can pick up better reception in your car radio. They've been adopted and used by Rhodes and Swartz. They're in a lot of test gear. Marconi used them. There's a friend of mine, Chris Ridley, here in the UK, who he works for one of the engineers at ICOM. Actually, I gave him some of these to repair. It's the Marconi. I can't remember what number it is. It's the SIGGEN. I think he uses 7 of them in there. So I think it's 4 or 7. I can't remember, but it's quite a number, and they are quite problematic. Anyway, I'll get these in, get these soldered in, clean the board up, and we'll get in and see what we've got. I'm quite confident that that will solve the problems. There may be other issues wrong with the unit, but we'll get this done, get this sorted out, and then we'll take a look. Okay, well, we've brought the unit back up with the new parts, the two new ICs installed. So, just run the self-test.